7x plus 19 is negative 2x plus 55. Okay. When you work with equations, there is on both sides, you want to work off the side that has the least x's. And the reason why you want to work the least is because that way you can avoid negative coefficients along the way if you can. So when you look at this, and I'll put my line down the middle to separate my two sides, which side has the fewest x's? The smallest coefficient of x, Mr. Cottrell. Correct. Negative 2 is less than 7, so we're going to remove all the x's from the right side. Add is the opposite of negative 2x. Correct. So we'll add 2x to both sides. Gets them off this side, because remember, our goal is to get one side with 0 x's and one side with 0 x's and the side with x's with 0 numbers. So 7 plus 2 turns it into 9. Notice I crossed off my negative 2 and my plus 2x. How do I figure out what has to go in the box? Correct. Notice all my x's are on the left side of my equal sign now, so I'm going to zero off the numbers. Let's see, 55 is almost 20. 55 minus 20 is 35, so add the 1 back in I took away. Do you guys agree that's 36? Yeah. So, what does x have to be? Equations with variables on both sides. We've kind of done it in the blocks. I didn't really tell you what we were doing, but you guys can see we're getting all the x's to one side. Let's do this example. Is everybody good with example 1? Four x plus 27 equals 3x. I'm about to violate my rule. So again, here's my line. And if you guys don't need my line, don't use my line. Now, which side has the fewest x's, left or right? Right. The right does. But in solving an equation, our goal is to get one side to have nothing but variables and one side to have nothing but numbers. So notice that the right side, while it has fewer x's, only has x. So therefore, even though we're going to be taking a bigger amount away, we're going to take them off the other side. Because the goal is one side with x's, one side with numbers. Well, the right side already has 0 numbers. So we'll take off 4x this time. Again, because the right side only has numbers, we'll take all the x's over, or excuse me, only x's, we'll take it over there. 3 take away 4. So now what do we have to do to finish up? Remember that commutative property too? If you don't like the variable being on the right side of your answer, you're allowed to flip it. Negative 27 equals x, or x equals negative 27. Questions on example 2. Okay. Let's go to 3. just like we saw yesterday, we may have to do multi-steps. So before we're even ready to get it back to something like example 1, because notice in example 1 it was kind of simple. Each side had a variable term and a constant term. By the way, what does the word constant mean? If we say something is constant, don't lean back on my chairs, please, for on the floor. What's something that's constant never does what? Casey Love?
It never stops.
Not necessarily. Not what I'm looking for. Casey Cottrell.
It never changes.
Never changes. Okay? So terms like 19 and 55, they never change. Terms like 7x and 2x, they change depending on what we put in for x. So terms that never change are constants. So notice here in example 1, you had a variable term and a constant term. We were ready to go. Here, variable term, constant term, variable term. Here, we got more than just a constant and a variable term. So we're going to have to use what we did in Unit 1, and we're going to have to simplify. So, let's work on simplifying. How in the heck are we going to get rid of this parentheses? And Joel, I know you got this. Okay? Yes, and I just drew her name blank. Clarissa. Yes. Okay? So the first thing we'll do is we'll have to distribute. So forget the right side's even here for right now. Let's work on the left. So Clarissa, what's the... Correct. Remember, anything inside gets taken times 9. If you want to write it out, you may write it out, but if you can just do my arrow thing, that's fine too. Still got a minus 7m over there. Dabs, what's the right side going to become?
15m and 10.
Awesome. Now notice the left side still isn't simplified because I have 2 variable terms on the left side. They're together, so I'm just going to put them together.
2m.
Awesome. So we've done all this. We haven't even started on the algebra part yet, really. Okay. Notice that both terms have a variable, both terms have a constant. We want to work off the left. The left, which side has left hand?
2.
So what am I going to do with them?
Minus 2 to get 15.
Correct. Remember, do unto one as you do unto the other. When I say both sides unto the other side of the equation, other side of the equal sign. Be cautious. You take away the 2m, this 36 is still negative. I believe Quentin said that was 13, right?
Yep.
Ned, pick us up from here.
You add 10 to both sides.
Yes, you do. So Ned, what do you get?
You get negative 26 equals 13m.
Wyatt, almost done. What's our last step, Mr. Eldridge? Correct. And we get? You got it, kind of 2. Negative 2. Questions on that? Okay. Let's talk about some special equations. Take a look at this one. Yes, Mr. Guttrell. Left side's good. One variable, one constant term, one variable term. Right side, Casey's correct, we got to simplify. And the way that we simplify, well, Sweeney, what are we going to do?
Add.
Not add. What's that 6 outside parentheses? What operation does that do with us? Getting warmer.
Wait, no. I don't know.
Yes. So Kinley, what do you get when you take 6 times 4 and 6 times r?
6.
Very good. Notice anything here before we go too much farther?
They look exactly the same.
Goofy's going to happen. They look exactly the same. Okay? Remember, when we solve an equation, for example, when we solve this equation, -2 is the value that makes both sides equal the same amount. When we solved example 2, -27 is what x would have to be for both sides to be the same. 4 is what makes both sides have the same number here. Well, here in this example, they look exactly the same. Look what's going to happen. Since they're the same, how am I going to get the r off of? How am I going to get the r off the right side? Okay. Notice again when we add the 6 r's, put them underneath what they're like. I'm not adding 6r to 24 because I can't, because they're not like terms. So here's the r's. Somebody said we get 0. So yeah. Huh. Both sides are the same, aren't they? This is an example of what we call in algebra an identity. Its answer is all real numbers. You can put any real number you want in there for r, and both sides will be the same value. Identities are going to appear when the variables go away, and you're left with a true statement. Or as you guys can see, somewhere along the way, your sides will look exactly the same. Okay? It's an identity. The solution is all real numbers. There's another special type of equation you'll have to deal with, and it would be something like this. Bless you. Now I know Casey knows what to do, but let's test somebody else. Riley, what are we going to do? Correct. And what do we get on the left side?
-12
Yes.
and 20 in.
I like it. Wyatt, what about the other side?
And you get 12 in.
How'd you get 12 in?
I mean 20 in.
Yes.
Minus 6.
Nice work so far, guys. Yelton, you notice anything goofy?
Yes, I do.
What do you notice?
That the variables are
The variables are both the same. So if we go to continue this and take off the 20 in, they both zero out. Does -12 equal -60? No. Okay. This is an example of an equation that has no solution. There is no real number we can put in for n that's going to make both sides of this equation the same. Notice, just like in the identity one that we did here, the variables are go away. As Liz noticed, the variables are the same on each side. Here, though, it's a true statement. 24 is 24. 8 will be 8. you'll get the same thing on both sides with no variables. There's an identity in all real numbers. Here, you get no variables, and it's not true. Remember on the Unit 1 test we had the, is it an open sentence, is it true, is it false? Anytime you have a variable, it's an open sentence. Because you can put in, whatever you put in for the variable depends on will change the value. Here, we worked it out, there's no more variables, it's no longer an open sentence, it's either true or false. If it's true, identity. If it's false, no solution. Question?